Right, section 2.8, probability and odds. We have two goals for today as I can find the probability of an event, and number two, I can find the odds of an event. First thing we have is the probability of an event is the likelihood that the event will occur due to chance. We also have things called outcomes. Outcomes are the different possible results of a probability experiment. Favorable outcomes are the outcomes for the particular event you wish to happen. The ones that we don't want to happen are unfavorable outcomes. So that would be the opposite of a favorable. We have the unfavorable outcomes. We have two types of probability. We have one called a theoretical. Probability is based on reasoning in which the possible outcomes are counted. And then we also have experimental probability. Experimental probability is based on the results of an experiment in which actual results are counted. For example, you could do, if you flip a coin and you want to just flip it one time, if you flip a coin, what's the probability that you're going to get a heads? It's going to be 50%. You're going to have a 50-50 chance of getting a heads if you just throw it. That's the theoretical. Experimental is actually if we toss it. Now, if we do the experimental, it's actually going to be the same thing. But if we do more coins, then what's going to happen is you might see that the experimental actually changes based upon the data that is collected. It might not always be the same as a theoretical. So for today, what we're going to be doing is looking a lot at the theoretical, but we want to know that the experimental is also a valid way to do probability. We also have the odds. The odds on an event that will occur is the quotient of the number favorable outcomes and the number of unfavorable outcomes. So we have two formulas that you have to know, one for probability and one for odds. For probability, we are looking at the favorable outcomes over the total outcomes. For odds, we are looking at the favorable outcomes over the unfavorable outcomes. Let's look at a few problems that work with these two formulas. So, number one, find the probability of an event. If you toss two coins, what is the probability that only one is heads? Well, first off, we're actually not tossing two coins. What we're actually doing is we're saying, hey, what if we did? So in this case, that would be an example of theoretical probability. So if you toss two coins, what is the probability that one is heads? Well, if I toss two coins, I could say coin one, and I could say coin two. So with coin one, it has two options that it could be. It could be either heads or it could be tails. For coin two, this could be heads and this could be tails. So what is the probability that only one is heads? So the combinations that I could say if this is heads, this can be heads. If this is heads, the second coin could be tails. If the first coin is tails, the second coin could be heads. And if I do it again, I could say tails and tails. So these are the four possibilities that I have. We want to find the probability that only one is the heads. So in this case, we have one that is ahead, and we have this one in which only one is ahead. This one won't work because this one includes two that are heads. So what we're going to do is we're going to use the number of favorable outcomes. So the favorable outcomes is how many have just one heads. In this case, it's 2. And what we're going to do is we're going to divide by the total number of outcomes, which in this case is 4. When we reduce, we get 1/2. Now you can write probability as a couple different ways. You could say 1/2, or if you wanted to, you could also say 50%. 50%. Let's do another one. Let's find the probability of choosing a blue marble from a bag of blue and yellow marbles. The number of blue marbles is 12, and the total number of marbles is 48. So I'm trying to find the number of blue marbles that I can choose. So I know that there are 12 blue marbles, and I know that there are a total of 48 in the bag. I always want to simplify my fractions, so I have to figure out how many times 12 goes into 48. So 12 goes into, I know 12 times 2 is 24. I know 12 times 3 is 36. And I know 12 times 4 is 48. So this will be 1/4. We could also write it as a percent, and we could say 0.25, which is 25%. There's a 25% chance that you're going to pull out a blue marble. Now be careful on the you practice, because you have to be really careful when you read this question. If you read it wrong, then you might get a wrong answer. All right, in example 2, what we're doing is we're finding the odds of an event. So we want to find the odds of choosing the letter A from a bag that contains the letters in the word Canada. So in Canada, I know that there are 1, 2, 3 A's. So those are my number of favorable outcomes. Those are the numbers that are going to go up top. The number of unfavorable outcomes is everything that is not an A. So if I count the numbers that are not A's, I have 1, 2, 3. So for my odds, I want to reduce it. I always want to reduce it when I can. So this would be 1/1. So I can write it as 1/1. We can also say 1, 2, 1. Or we can also say 1, 2, 1 using colon like that. So any of these answers is good. So if we say 1/1, 1/1, or 1/1, those are all good answers. The last type of problem that we're looking at is where we are finding odds from probability. So the probability of an event will occur is 0.43. What are the odds that the event will occur? So if this is 43, another way that I can write it is 43%. So 43% is the probability that this event will occur. Now, you have to know that percents are out of 100. So if I write 43 out of 100, this will be 43 out of 100. Now we don't have decimal points. We actually have real numbers that we're working with. So to find the odds, what I'm going to do is take the number of favorable outcomes that I have, which in this case is the top number because this is my probability. Probability is 43/100. So the number of favorable outcomes is going to be the same in both probability and odds. The number of unfavorable outcomes is everything that is not 43. So what I have to do
JP Archuleta, you have an item in the front office, JP Archuleta,
is take 43 divided by 100 minus 43, which will be 43 over 57. I can write it like this. I can write it like this. Or I can write it like this. Any of these answers are good to go.